Greetings, everyone. I hope everybody's good. What we're going to do today is we're going to continue exploring the solar system project. And what we would like to do is build on our knowledge of how to make an ellipse. You may recall in the last lesson we learned the definition of an ellipse, and we learned how to construct an ellipse. And we also learned how to turn ellipse into a tool. So I'm just going to refresh your memory how to do that. For this, you're going to need to access the actual sketch that you used to create your tool. So I'm going to go to a blank page that I have here. And here is actually an ellipse. Let me just do it from scratch so we can see. I'm just going to remind you how the ellipse tool works. You put the first focus and then the second focus. And then the third point is the radius control point for the circle that was used to create the ellipse. And depending on the size of this ellipse you want, you can drop this one, something like that. It is important to note that in our construction, the first focus we created is going to turn out to be the sun. If you remember from your astronomy physics classes, planets move around the sun in elliptical orbits, and sun is at one of the foci. It turns out that it is the first one. That's how we created the tool, so that we'll remember that the first one is always the sun. Now, what I recommend is you keep using your tool to first of all practice how to do this. So you go to the sun first, put the second focus somewhere else, make sure you open it so that you have a lot of practice creating first of all a chain of elliptical orbits. You're gonna need 8 or 9 of these depending on whether you believe Pluto is a planet or not. By the way, I believe it is a planet. I grew up thinking it's a planet. I like to keep it as a planet. But once you get a hang of this tool, you're going to realize literally in a matter of minutes you could create a system that is going to have as many elliptical orbits as you wish. And you could tweak things if you want certain orbits to be sort of a little bit have different eccentricities, orientations, etc. Depends how accurate you want to do. If you really want to be very accurate, you may want to consult some astronomy textbooks to see the spacing, etc. But I think for us, we're just having fun, so we don't need everything to be totally exact. So what I need you to do right now is go to Document Options, open a blank page, and let's start with creating at least one system so that we are beginning to understand how to put our earlier simpler system with the sun, earth, moon on an elliptical, this time elliptical orbit system. So I'm going to put my sun. This is the second focus. I'm opening the radius point. I'm going to put it right there. I just want to show you how you can, and it's probably always a good idea to remind yourself which one is the sun. So I'm going to call this one the sun. You may want to create a show hide button for these points, because once you like the dimensions of your ellipse, we're not going to really change that, but just in case. And you may want to edit the name of this so you remember what it is. So you may want to say something like hide F2 and then the radius point, so that you know what it represents. Okay, so let's hide those points. So you should have nothing but the sun right now. So let's actually put here the earth, and let's call it the earth so we know what it is. And what we're going to create here, just like we have done earlier, is let's create a system where you have an orbit for the moon of the of Earth. So let's actually create, and let's actually name these things. So this, let's call it moon orbit. And what we're going to do is we're going to now create a circle around the Earth with this radius that you could later change your mind about. I just want to show you something. This is something I wish I explained better last time. If you just go to your circle tool and create a circle around the Earth, just with that circle tool, as this point is independent of the Earth point, as you move the Earth point, it will not understand that it has to follow. So you're going to have this very bizarre behavior where the orbit of the moon is expanding. That's why I did not do it that way. So we're using the second way of constructing a circle, which is by center and radius. Construct circle by center radius. I think it's a little bit too big for our purposes. So I'm gonna make this maybe this much. And then you could put your moon, let's call it the moon. And I believe everything we need is ready for an animation. Remember how animation works? You select whatever is traveling. The computer understands, Sketchpad understands that these points are on their respective paths. So edit, action buttons, animation. Let's have the Earth go at medium speed and maybe the moon go fast. And let's OK that. And let's test that. So this is a lot like the early construction we had, except now the Earth is moving in an elliptical path. Observe something very, very fascinating about this construction. Just like in real solar system, as the Earth gets closer to the sun, it speeds up, and as it goes farther out, it slows down. It is not obvious why the construction leads to it. When you watch the original construction, this becomes kind of obvious, but it might be a fun thing for you to contemplate why unintentionally we have this fabulous effect. This is one of the, I believe, Kepler's laws that planets sweep equal areas in equal times. So that means when the planet is farther from the sun, it has to behave, it has to slow down. Alrighty, so here is a simple system. If you're picky and you really want some cool effects, you may say, yeah, but I want my sun to have some thickness. You could use what we did before, select the sun, create a segment here. Let's actually call this the sun radius. You can now select the sun, select the radius, construct the circle of the sun, construct the interior. Green sun I don't think would work. Let's make it yellow. And you could do all kinds of things. So here is the sun. Now again, the Earth also doesn't have any thickness, so let's maybe have some thickness for the Earth too. It's always a good idea, especially when you're working with a complex system that has 8, 9 planets, their moons, etc. So let's give some, oops, I wanted to call this Earth radius. So let's give Earth also some thickness. So circle by center radius. Oops, it became coincident with the other one. So you select the Earth, construct its interior. This time, yeah, let's just go with the Earth color. That might be fine. Gonna make this a little bit smaller, this a little bit smaller. Okay, and here is your animation. Okay, now, oops, so this wasn't a good idea. As you saw there, the orbit of the moon was so far out that it actually went into the sun. So you may want to play around so that this doesn't happen. That would not be a pretty animation. Okay? So here is a simple system where this time the sun Earth and the Moon behaves pretty much similar to what we had before, except the path is elliptical for the Earth. And you have this fabulous effect of the planet slowing down as it is further away from the sun. Alrighty, we shall continue with this. I hope you had a good time. Take care.